Hello and welcome to video number 18 in this series. And in this video I'll review using the quadratic formula to solve quadratic equations in situations where factoring either isn't possible or it isn't particularly easy. So remember, we have our definition of a quadratic equation: ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. And the quadratic formula is a formula for solving this equation, so finding the roots. And it's given by this formula. So it starts with a minus b, and then this symbol here, plus minus, means it's going to give us potentially two solutions, one where we use plus and one where we use minus. And then we have the square root of b squared minus 4ac, and then that whole thing is divided by 2a. So it's kind of an ugly formula, but it's an effective one, and it works to solve this quadratic equation. So let's run through a few examples to see how to use it in practice. So the first example I'm going to do is x squared plus x minus 6 equals 0. So we have to, when we're using the quadratic formula, we have to know what a, b, and c is. So a in this case is 1, b is 1, and c is minus 6. So x will be equal to minus b, so minus 1, plus or minus square root, and then we have b squared, so 1 squared, minus 4, and then a is 1, and then c is minus 6. And then the whole thing gets divided by 2 times a, 2 times 1. So we got minus 1 plus minus. So this square root b squared minus 4ac, this thing is called the discriminant, the b squared minus 4ac. And that can either be positive, negative, or 0. If it's positive, then we end up with two solutions. If it's 0, we end up with one solution. And if it's negative, we end up with no real solutions. So this b squared minus 4ac plays a critical role in how many solutions there are. So let's see whether we have a positive number here, a negative number, or 0. And that will tell us how many solutions we have. So in this case, we've got 1 minus 4 times 1 times minus 6. 4 times 1 times minus 6 is minus 24, but we're subtracting minus 24, so that's the same as adding 24. 1 plus 24 is 25. We've actually got a number here that's positive, so we've got two solutions, but it's also a perfect square, so we can take the square root of it to get 5. And then we're going to divide that by 2. So we've got two solutions, one where we use the positive, one where we use the negative. So the one with a positive would be minus 1 plus 5 is going to be 4, divided by 2 will be 2. And then the other solution, minus 1 minus 5, so minus 6 divided by 2 will be minus 3. So this example, this was actually an example we looked at in the last video, and we factored it. And it factored into x plus 3, x minus 2. So we could have done this example just by factoring and seeing that the two solutions are x equals minus 3 and x equals plus 2. But for illustration, I wanted to show you how the quadratic formula works in an example that we actually already know what the answers are. So this confirms our factoring method. Let's do an example where we only have one solution. So in this example, the discriminant is going to turn out to be 0. So we'll do 4x squared minus 12x plus 9 equals 0. So let's use our quadratic formula. So we're going to have minus b. b is minus 12, so minus 12 is plus 12, plus minus square root of 12 squared. The fact that it's negative doesn't really matter when you're squaring it, so I'm just, to save a little bit of writing, I'm just going to write 12 squared instead of minus 12 squared. It amounts to the same thing. Minus 4ac. And then the whole thing divided by 2a, which is 8. So we got 12 plus or minus, got 144, and then we got minus 4 times 4 times 9. So we got minus 16 times 9. 16 times 9 is 144. So we got 144 minus 144. So we've got plus or minus 0. And then divided by 8. So that's going to be 3/2. And I think that we did this example in the last video as well. Or if we didn't, we can see that it must factor because we're getting a nice rational number here. And it factors into 2x minus 3 squared. So x equals 3/2 is the single solution, just one solution here. So let's do a third example, one in which the discriminant is going to be negative and we have no real solutions. So we'll do x squared plus 4x plus 5 equals 0. So x is going to be, using the quadratic formula, minus b, so minus 4, plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. So we're going to have minus 4 plus or minus square root of, let's see, 16 minus 4 times 1 times 5. So 16 minus 20, so minus 4. So we've got to try and take the square root of a negative number, which we can't do when we're restricted to real numbers. So no solution for this one. No roots. So these examples illustrate how the discriminant plays a key role here. If it's positive, we end up with 2 roots. If it's 0, we end up with 1 root. And if it's negative, we end up with no roots. In the 2 examples where we got solutions, we could have factored and saved ourselves having to use the quadratic formula. So the quadratic formula is most useful when we can't do this, when we can't factor, or when factoring is really challenging. So let's do an example where we can't do the factoring and see what the result of using the quadratic formula in that kind of example is. So this is going to be example number 4. So we're going to do 4x squared minus 8x plus 1 equals 0. So using the quadratic formula, we start with minus b. So b is minus 8, so minus 8 be plus 8. Plus or minus square root of b squared. So b squared b is minus 8, but minus 8 squared is the same as 8 squared, so just to save some writing, I'll just write 8 squared, and then minus 4a is 4, and c is 1. And divided by 2 times a will be 8. So we got 8 plus or minus 64 minus 16, which comes to 48. Divided by 8. Okay, so I know I've got two solutions here because I've got a positive discriminant. Let's see if I can clean this up a little bit. Let's do 8 plus or minus the square root. So 48, if I factor that into a perfect square and another factor, then I could pull out the perfect square piece. I could pull that out of the square root. So what I mean is 48 is also equal to 16 times 3. So now I can take the square root of 16. So I could pull that out of the square root sign as a 4, because the square root of 16 is 4. So now I'm going to have 8 plus or minus 4 times the square root of 3. And now I'm going to simplify this just by taking out the common factor of 4 here. So because I'm dividing by 8, so I've got 8 divided by 8, so that's 1, and then I'm plus or minus 4/8 of the square root of 3, so otherwise, in other words, I could write it as the square root of 3 divided by 2. So this is an exact way to write the two roots, 1 plus square root of 3 over 2 and 1 minus square root of 3 over 2. If we want to express this as a decimal, we're going to have to go to our calculator, and it turns out that 1 minus the square root of 3 over 2 is 0.134, and 1 plus the square root of 3 over 2 is 1.866. So this is an example where factoring would have been a challenge, because we've ended up with an irrational pair of answers, or a pair of irrational answers. If we wanted to draw what this quadratic equation looks like, this one, we know it's going to be a parabola that is more like a valley than like a hill, because it's got a positive coefficient on the x squared. It's going to pass through these 2 points on the horizontal axis. So if this is the x-axis, this is the y-axis, 0 is in the middle, and then 1 and 2. It's going to cross the axis somewhere here and somewhere here. And it's actually also going to reach a minimum at the coordinate of x equal 1, y equals minus 3. So here. So it's going to kind of look something like this. It's going to go down and then up. Oops. It's going to be more like this. Kind of like that. So let's do another example where either factoring is not possible or it's just really challenging. So let's do this example. So 24 x squared plus 22x minus 35 equals 0. So it turns out that this is possible to factor, but it's hard to imagine where to start with this. So instead we're going to use the quadratic formula and see where we end up. So using the quadratic formula, so we start with minus b, so minus 22, plus or minus square root of b squared, so 22 squared, minus 4a, and then c, and then we're going to divide by 2a, so divide by 48. So this is what we get when we plug in our numbers into the quadratic formula. And so I can start writing down what I've got. So I've got minus 22 plus or minus, and then I've got the square root. And now we're starting to get into some big numbers. So all the examples up to this point in the videos, we've been able to do just using our knowledge of times tables and mental arithmetic. At this point, this is starting to get into territory where you're probably going to have to go to a calculator, which is, it's fine. So that kind of illustrates one drawback to the quadratic formula, because often we do end up, especially in this discriminant part of the quadratic formula, is you're working with often fairly big numbers and then you're having to take the square root. So you're going to have to start using a calculator when you're applying the quadratic formula. And so that illustrates how if you can factor, that's definitely the way to go. So when you see a quadratic equation, your first instinct should be, can I factor this? And if after a few minutes you're struggling to find nice, clean, easy factors, then go to the quadratic formula. Your instinct should not be to go immediately to the quadratic formula and your calculator. So at this point, we can't really factor this very easily. So going to a calculator to figure out what this comes to is pretty much the only thing we can do. So if you do calculate this out using a calculator, you end up with 3,844 as the discriminant. So we know we're going to have two solutions because this is positive. And then if we take the square root of this number, turns out this is actually a perfect square. So we can take the square root. Comes to 62. And then all of these numbers are even, so we could pull out a factor of 2, and we'll have minus 11 plus or minus 31 over 24. And so if we do minus 11 minus 31, so that's going to be minus 42. And then minus 42 over 24, we can reduce that to minus 7 over 4. And then minus 11 plus 31, so that's going to be 20 over 24, so we can reduce that to 5 over 6. So those are our two roots for this example. So given that we've got rational numbers here, it turns out that we could have factored this, and the factors, we'll go this way. We end up with 4x plus 7 times 6x minus 5. So this is what gives rise to the root minus 7 over 4, and this factor is what gives rise to the root 5 over 6. So pause the video at this point and work on the next two problems that I'll put up and see if you can use the quadratic formula successfully to find the roots of the quadratic equations that I'll put up here. See if there's two solutions, one solution, or no solutions. So the first one, let's do 2x squared plus 3x minus 1 equals 0. And then the second one, let's do 10x squared minus 19x plus 6 equals 0. Okay, let's see how you did with these two. So x equals, so minus b, so minus 3 plus or minus square root b squared, so 3 squared minus 4, a is 2, c is minus 1, all divided by 2 times a is 4. So I have minus 3 plus or minus, so I have 9 minus 4 times 2 times minus 1 is minus 8. Minus minus 8 will be plus 8. So 9 plus 8 is 17. Okay. And if we write this as decimal numbers, so we'll have minus 3 minus root 17 all divided by 4. That gives us minus 1.781. And minus 3 plus root 17 over 4, that gives us 0.281. And then this second example, so we're going to have x equals, so minus b, be 19, plus or minus square root b squared, so 19 squared minus 4, a is 10, and c is 6, all divided by 2a 20. So we got 19 plus or minus, and then if we evaluate this using a calculator, 19 squared minus 4 times 10 times 6, we get 121. And that's nice because 121 is a perfect square. So square root of 121 is 11. So we've got 19 plus or minus 11 over 20. So 19 minus 11 will be 8. So 8 over 20, if we reduce that, we get 2 over 5. And the other root, 19 plus 11, would be 30 over 20, so 3 over 2. So those are our two roots, 2/5 and 3 over 2. And given that we've got rational solutions here, that implies that this, we could have factored this. So let's see what the factors are. So it must be, one factor must be 5x minus 2. That would give us the 2/5. And then the other one must be 2x minus 3. That gives us the 3 over 2. And if we just check, so this provides a useful check that we've done our quadratic formula correctly. We're going to have 5x times 2x, that'll give us a 10x squared. We got minus 2 times minus 3, that would give us the plus 6. And then we got minus 4x minus 15x, that gives us the minus 19x. So that's a nice check that we've done this correctly. So that's all for this video, and we've got 2 videos left in this series, and we're going to cover inequalities in those last 2 videos. So something a little bit different, and we'll start with linear inequalities in the next video.